Hello and welcome back to Engineers Olympiad. We're doing the numerical questions for the topic weight volume relationships in geotechnical engineering. This is the video lecture number 5 for the same series. 4 video lectures are already uploaded on the channel Engineers Olympiad. You can watch those videos before watching this video. So let's get started. Question is, a soil mass in its natural state is partially saturated, having a water content of 17.5% and a void ratio of 0.87. Determine the degree of saturation, total unit weight, and dry unit weight. What is the weight of the water required to make a mass of 10 cubic meter volume to get saturated? Assume G to be 2.69. All right. So we have two parts for the same question. So let's solve one by one, beginning with the first part. All right. So what data has been provided in the question itself? A soil mass in its natural state is partially saturated, having a water content of 17.5% and a void ratio of 0.87. Determine the degree of saturation, total unit weight, and dry unit weight. This is the part A of the question. Then we'll move to the part B. So we have been given the water content and the void ratio. We have to determine the degree of saturation, total unit weight, and dry unit weight. So let's start with the degree of saturation. We know the generalized equation ES is equal to WG. That means S is equal to WG divided by E. We have all the three things given in the question. So S is equal to water content is 17.5%. G, we have been asked to use 2.69. So multiplied by 2.69 divided by E. E is the void ratio that we have been given as 0.87 in the question. So according to the calculations, degree of saturation is equal to 54.10%. All right. So we have calculated the degree of saturation for this question, which was the first thing that we needed to find out. So degree of saturation is how much? It is 54.10%. All right, we were given water content and the void ratio, and we found the degree of saturation. Next thing that the question demands to find is the total unit weight and the dry unit weight. So let's find the total unit weight first, that is the bulk unit weight. All right, so the total unit weight or the bulk unit weight will be given by the generalized equation, that is G plus SE multiplied by the unit weight of the water divided by 1 plus E. Alright, so let's substitute the values and find the value for the total unit weight. Alright, this thing, total unit weight. So let's calculate the total unit weight. G is 2.69. Degree of saturation we just calculated as 54.10%. 54.10% multiplied by the void ratio, which is 0.87. All right, and unit weight of water is 10 kilonewton per cubic meter. 1 plus E is 0.87. All right, by calculations the total unit weight or the bulk unit weight is equal to 16.90 kilonewton per cubic meter. All right, so the total unit weight or the bulk unit weight that the question asked to find is equivalent to 16.90 kilonewton per cubic meter in this case. All right, the next thing that we need to find is the dry unit weight. Since we know the total unit weight or the dry unit weight, we can easily find the total unit weight or the bulk unit weight. We can easily find the dry unit weight, which is equal to dry unit weight is equal to total unit weight or the bulk unit weight divided by 1 plus water content. So the dry unit weight is bulk unit weight or the total unit weight, which is 16.90 kilonewton per cubic meter divided by 1 plus water content, that is 17.5%, as already given in the data. So by calculations, dry unit weight is equal to 14.38 kilonewton per cubic meter. Right? 14.38 kilonewton per cubic meter. All right, So with this, we have completed the part A of the question, wherein we were asked to find the degree of saturation. That we have found out. Total unit weight done, and dry unit weight has also been found out. Now the next part of the question says, what is the weight of the water required to make a 10 cubic meter volume of soil to get saturated? Because in the question it was given that the soil mass is in natural state and it's partially saturated. Now we have to calculate the weight of water required to make volume of 10 cubic meter of this soil fully saturated. For that, I'll be calculating the saturated unit weight first. Saturated unit weight is equal to G plus E, unit weight of water, divided by 1 plus E. That means saturated unit weight is equal to G is 2.69, E is 0.87, unit weight of water 10 kilonewton per cubic meter, divided by 1 plus E is 0.87, so it's 1.87. All right, my calculations, the saturated unit weight is equivalent to 19.03 kilonewton per cubic meter. 19.03 kilonewton per cubic meter. This is the saturated unit weight. And we know the saturated unit weight this is mass divided by volume. Saturated unit weight we have calculated as 19.03. It will be mass of the soil in saturated state divided by volume. We have been asked to find how much water do we require to add to 10 cubic meter volume of this soil to get fully saturated. So volume is 10. So by calculations, mass of the soil in saturated state is equivalent to 190.3 kilonewton. All right. And the bulk unit weight or the total unit weight was how much? It was 16.90 kilonewton per cubic meter. The bulk unit weight or the total unit weight is 16.90 kilonewton per cubic meter. Bulk unit weight is also equivalent to mass per unit volume, and mass of the soil in the bulk state or in the natural state. So this is mass of the water, mass of the soil in the bulk or the natural state, I may say, divided by volume is same 10. Here I'll put it here. This will go here. So 16.90 is equal to mass of the soil in its natural state divided by 10. So mass of the soil in natural or the bulk state is equivalent to 169.0 kilonewtons. All right, mass of the soil in saturated state is 190.3 kilonewton. Mass of the soil in saturated state is how much? 190.3 kilonewton. Mass of the same soil in natural state is how much? 169.0 kilonewton. That means more water, more weight of water I'll put it like this. So more water that is required to be added is how much? That is this minus this. 190.3 mass of the soil in saturated state, that is 190.3 kilonewton, minus mass of the soil in the natural or the bulk state, that is 169.0 kilonewtons. That is equal to 21.3 kilonewton. All right, so that's how we arrived at the mass or the weight of the water which is required to be added to 10 cubic meter volume of the same soil to get it fully saturated. All right, because the mass of the soil in the saturated state, it came equivalent to 190.3 kilonewton, and in bulk state or natural state it was equivalent to how much? It was equivalent to 169.0 kilonewtons. So the more water that is required to be added to this soil which is in its natural state and is partially saturated to make it fully saturated is 21.3 kilonewton. All right, so with this we have completed this question in all respects. Let's move to the next one. Question is, the void ratio of a clay sample is 0.5 and the degree of saturation is 70%. Compute the water content, dry and unit weights of the soil and assume G equal to 2.7. Right, so let's do this question. The data given is void ratio is 0.5 and degree of saturation is 70%. We have to compute the water content, the dry and the unit weights of the soil, and we have to assume G, that is specific gravity of soil solid particles, as 2.7. All right, using the generalized equation ES is equal to WG, I have to find the water content. So water content is ES by G. So water content is E as given in the question 0.5. S, the degree of saturation, 70%. All right, so 0.70 divided by G, that we have to use as 2.7. By calculations, water content is equal to 12.96%. Water content is equal to 12.96%. Next, we have been asked to find the dry and the unit weight. So dry unit weight is given by the equation or the formula 1 plus E. So dry unit weight is G is 2.7, unit weight of water is 10 kilonewton per cubic meter, 1 plus E is zero point 0.5, so this is 1.5. So the dry unit weight is equal to 18 kilonewton per cubic meter. All right, next thing that we have to find is the unit weight, that is the bulk unit weight. We know the alternate equation. Dry unit weight is bulk unit weight 1 plus water content. Dry unit weight we have calculated, it's 18.0 kilonewton per cubic meter is the bulk unit weight. 1 plus water content is 12.96%. That we calculated in the very beginning, 12.96%. So by calculations, the total unit weight or the bulk unit weight in this case is 20.33 kilonewton per cubic meter. All right, so we have completed the question in all respects. We have found the water content, the dry unit weight, and the total unit weight. All right, moving on to the next question. We're trying to solve as many questions as possible. Next question is, a sample of soil compacted according to standard Proctor test has a unit weight of 20.58 kilonewton per cubic meter at 100% compaction and at optimum water content of 14%. What is the dry unit weight? What is the dry unit weight at 0 air voids? Then the question says, if the voids become filled with water, what would be the saturated unit weight? Assume G equivalent to 2.67. All right, so let's solve this question. Question is based on the data as found out during the standard Proctor test. All right, the first thing that the question is demanding us to find is what is the dry unit weight. We have been given the unit weight or the bulk unit weight and the water content. Optimum water content is 14%. We have to find the dry unit weight. Dry unit weight, First, I write the bulk unit weight or the total unit weight. That is given as 20.58 kilonewton per cubic meter. Optimum water content in the standard Proctor test at 100% compaction. Optimum water content is 15%, 14% as given in the question. All right. So the first thing that we have to find is the dry unit weight. All right. So the dry unit weight, it is equivalent to bulk unit weight or the total unit weight divided by 1 plus water content. So the dry unit weight is equivalent to 20.58, which is the bulk unit weight or the total unit weight divided by 1 plus water content. Water content is 14%. By calculations, dry unit weight is equal to 18.05 kilonewton per cubic meter. All right. So this is how we found the dry unit weight. Now we have to find the dry unit weight at 0 air voids. All right. Dry unit weight at 0 air voids is equivalent to 1 plus Wg. All right. This is the dry unit weight at 0 air voids. G is 2.67. Unit weight of water is 10 kilonewton per cubic meter. 1 plus water content is 14%. And the specific gravity of solid particles is 2.67. By calculations, this is equal to 19.44 kilonewton per cubic meter. All right, so we have calculated the dry unit weight at 0 air voids using this equation, because we know that the dry unit weight is equal to 1 minus percentage air voids G gamma W divided by 1 plus Wg. This is the generalized equation, and when air voids become 0, this equation becomes this. All right, so that's why I use equation this for finding out the dry unit weight at 0 air voids. Generalized equation is this: 1 minus percentage air voids G gamma W 1 plus Wg, but at 0 air voids this thing will be not present, so the equation will transform to this form: G gamma W 1 plus Wg. That's how I arrived at my dry unit weight at 0 air voids. All right, moving on. What do we need to find next? All right, so this becomes the part 2 of the question, that is, if the voids become filled with water, what would be the saturated unit weight? All right, if the voids become filled with water, what would be the saturated unit weight? Let's find it out. Saturated unit weight, as given by the generalized equation, is equal to G plus E gamma W divided by 1 plus E. All right. Or before doing that, let me find the dry unit weight using this equation, so that I will be arriving at the void ratio. That's how I can find the saturated unit weight. So first we need to find the void ratio. That is, will be using this equation. Dry unit weight we have calculated in the very beginning. It was 18.05. So 18.05 kilonewton per cubic meter. G we have to use as 2.67. Unit weight of water is 10 divided by 1 plus C. By calculations, E is equal to 0.479 in this case. With the help of E, I can find the saturated unit weight now. That is G plus E, 1 plus E. So saturated unit weight is equal to G 2.67, E is 0.479, unit weight of water is 10 kilonewton per cubic meter, and 1 plus E is 0.479, so it becomes 1.479. By calculation, saturated unit weight is 21.29 kilonewton per cubic meter. This is the saturated unit weight. All right. So what would be the saturated unit weight if the voids become filled with water? That means there is no air phase and the soil mass reduced to the two-phase system from the regular three-phase system, and all the voids contain only water and there is no air phase. All right, and the soil becomes completely or fully saturated. So we have completed this question, which was based on the data of a standard proctor test in all respects. All right, we have computed the dry unit weight, the dry unit weight at zero air voids, and the saturated unit weight as well. Moving on to the next one. The next question is, in a field exploration, a soil sample was collected in a sampling tube of internal diameter 5 centimeters below ground water table. The length of the extracted sample was 10.2 centimeters and its weight was 387 grams. If G is 2.7 and the weight of the dried sample is 313 grams, find the porosity, void ratio, degree of saturation, and the dry density of the sample. All right, so let's solve this question. All right. In a field exploration, a soil sample was collected in a sampling tube with internal diameter as 5.0 centimeters below groundwater table. The length of that collected sample was 10.2 centimeters and the weight of the sample that was collected was 387 grams. Then it was dried subsequently and its weight was found as 313 grams. So let me find the water content first. Water content is equivalent to what was the weight of the sample as extracted. It was 387 grams minus what was the weight of the dried sample, 313 grams. 313, so it becomes divided by 313. Water content is equal to 23.64%. So by calculations, this water content becomes how much? It becomes 23.64%. With the help of this, we'll find the volume of soil solids, which is mass of solids divided by G and density of the water. Volume of soil solids is mass of solids is how much? This much, because after drying, we're only having the mass of the soil solids, that is 313 grams, divided by G is how much? As given in the question, we have been asked to use it as 2.7. So 2.7 over here. Density of water, 1 gram per cc. So according to the calculations, we'll have volume of soil solids as 115.92 cc. Alright. After that, we'll find the total volume. Total volume of soil sample, that is how much? How can we find that? Because we know that during the field exploration, when the soil sample was collected in a sampling tube, that is having diameter as this much and the length of the collected sample was this much. So we can easily find the volume of the collected sample. That is how much? It is a sampling tube, so volume will be pi by 4 d square into L. So d is how much? 5 centimeters and length is 10.2 centimeters. Yeah, 10.2 centimeters. So volume will become 200.175 cc. 200.175 cc will be the volume. All right. Now we know the volume of the solids. We have calculated using this equation. We know the volume of the soil sample. We have calculated using making use of the dimensions of the sampling tube. Now we can very easily calculate volume of voids, which is equal to total volume minus volume of soil solids. So volume of voids is total volume is 200.175 cc minus volume of soil solids, that is how much? 115.92 cc. 115.92 cc. So by calculations, volume of voids is equal to 84.25 cc. 84.25 cc. All right. Now, what we have to find exactly as per the question: find the porosity, void ratio, degree of saturation, and the dry density of the sample. All right. So let's do porosity first. Porosity, as you know, it is defined as the ratio of volume of voids to the total volume. We know volume of voids 84.25 cc. We know total volume 200.175 cc. So by calculations, it is equivalent to 42.08%. In this case, porosity is equal to 42.08%. Next, we have been asked to find the void ratio. Void ratio, denoted by E, is a ratio between volume of voids to the volume of solids. Volume of voids is 84.25 cc. 84.25 cc divided by volume of solids, that is how much? 115.92 cc. So here it is 115.92 cc. By calculations, void ratio is equivalent to 0.726. All right. So we have found porosity, we have found the void ratio. Now we have to find the degree of saturation and then the dry density of the sample. All right. So degree of saturation. Degree of saturation as per the generalized equation ES is equal to WG is WG by E. We know all three. We can find the degree of saturation. Water content is how much? The thing we found in the very beginning, 23.64%. So it is 23.64%. G we have to use as 2.70 and E we just calculated as 0.726. 0.726. So degree of saturation is equal to 87.91%. This is the degree of saturation, 87.91%. And the last thing that the question asks us to find is the dry density of the sample. Dry density you can calculate using this equation. Dry density is G rho W divided by 1 plus E. So dry density is G is how much? 2.70. Density of water is 1 gram per cc. 1 plus E we have calculated as 0.726. So 0.726. By calculations, dry density is equal to 1.56 grams per cc. All right. So we have calculated each and everything, and we have completed question in all respects. All right. So this was the question based on the data on as per the field exploration test, during which we extract a soil sample, we collect it, and in this using a sampling tube of certain dimensions. All right. So that's how we proceeded with the question, and we found each and everything that the question asked us to find, like the porosity, white ratio, degree of saturation, and the dry density of the sample. All right, so that's how we solve questions like these, which in which a sampling tube is used during the field exploration test. All right, moving on to the next one. Question is, a saturated sample of undisturbed clay has a volume of 19.2 cubic centimeters and it weighs 32.5 grams. After oven drying, the weight reduces to 20.2 grams. We have to determine the following, like water content, specific gravity, void ratio, and the saturated unit weight of the clay sample. All right, so let's do this. So the question says a saturated sample of undisturbed clay has a volume of 19.2 centimeter cube, and the mass before oven drying and after oven drying is this and this much. So the first thing that we'll calculate is the water content. So the water content will become water content, mass of the clay before drying 32.5 grams, mass after oven drying is how much? It is 20.2 grams. 20.2 grams divided by 20.2 by calculations, water content is equal to 60.89%. So the part first is complete. We have found the water content, which is equal to 60.89%. Next thing we have to calculate is the specific gravity. See how I'll be calculating specific gravity. First, I'll make use of this equation, dry unit weight. Dry unit weight is equivalent to how much? Mass per unit volume. But mass in which state? In dried state, that is 20.2 grams divided by volume, that is 19.2 cubic centimeters. 19.2. By calculations, dry unit weight is 1.05 grams per cc. Dry unit weight is equal to how much? It is 1.05 grams per cc. We can also make use of alternate equation for the dry unit weight. That is, dry unit weight is G gamma W divided by 1 plus E. And also we know that ES is equal to WG. Alright. And if you can see here in the question says a saturated sample of undisturbed clay. So it's fully saturated, S is 1. So when S is equal to 1, E becomes equal to WG. E is equal to W. Water content, we found it as 60.89%. So 0.6089 G. Let me call this as equation first. And let me substitute its value over here so that I can find the specific gravity. Alright, let me write it again. Dry unit weight is G gamma W 1 plus E. Dry unit weight, as we have calculated, it is 1.05 grams per cc. So 1.05 G is what we need to find. Unit weight of water is 1 gram per cc divided by 1 plus E. We know E, will substitute the value from equation first, that is 0.6089 G. Alright, we have substituted the value of equation 1 over here, and this became equivalent to this. Upon calculating, it becomes 1.05 plus 0.639 G is equal to G, or G is equal to 2.90. Alright, so that's how I calculated the specific gravity, making use of these equations, the generalized equation and the equation for the dry unit weight, because volume was given and the dry mass of the sample was given. I found the dry unit weight first, and making use of the alternate equation and the generalized equation, we arrived at the specific gravity. All right, so this thing is done. Specific gravity we found equal to 2.90. Next thing is the White ratio. All right, White ratio we have to find. White ratio, using equation 1, White ratio is 0.6089 multiplied by the specific gravity. Now we know the value of the specific gravity, we can find the White ratio. White ratio is 0.6089 multiplied by G. G we have found equivalent to 2.90, so White ratio becomes 0.6089 multiplied by 2.90, it becomes equal to 1.76. So White ratio is 1.76. All right. The last thing that the question asks us to find is the saturated unit weight of this clay sample. Saturated unit weight, using the generalized equation G plus E divided by 1 plus E. So saturated unit weight is equal to G is how much? 2.90. E we calculated 1.76. Unit weight of water 1 gram per cc divided by 1 plus E, that it is 1 plus 1.76, it will become 2.76. By calculation, saturated unit weight is 1.68 grams per cc. So we have completed the question in all respects. We have found the water content, which was equivalent to how much? 60.89%. Specific gravity 2.90. White ratio, how much? White ratio was equivalent to 1.76, and the saturated unit weight 1.68 grams per cc. All right, moving on to the next one. Question is, an undisturbed sample of soil has a volume of 29 cubic centimeter and it weighs 48 grams. The dry unit weight of the sample is 32 grams. The value of G is 2.66. Determine the natural water content, the in situ white ratio, degree of saturation, and the saturated unit weight of the soil based on the data given. All right, so let's solve this question. Question says an undisturbed sample of soil has a volume of 29 cubic centimeters and it weighs 48 grams, and the dry unit weight of the sample, this is not the unit weight, this is the dry weight of the sample, is 32 grams. All right, so the mass of the soil before drying is 48 and after drying it is 32 grams. So I'll be finding the water content first. Water content is mass before drying, that is how much? 48 grams. Mass after drying, 32 grams divided by 32, so it is equal to 50%. Water content is 50%. So we have found the natural water content, which is 50%. Now we have to find the in situ white ratio. All right. For that, let me find the bulk unit weight first. All right. Bulk unit weight is weight by volume. What is the weight in the bulk or the natural state? How much? 48. What is the volume? Volume is 29. So it becomes 1.655 grams per cc. Weight was 48 grams and the volume, it was 29 cc's. So the bulk unit weight becomes 1.655 grams per cc. Dry Unit weight is again weight per unit volume, but the weight in the dried state, weight in the dried form is 32 grams. 32 divided by volume is same, 29 cc. So upon calculating, it becomes 1.10 grams per cc. This is the dry unit weight and this is the bulk unit weight. All right. Now making use of this equation for the dry unit weight is G gamma W 1 plus C. Right. So the dry unit weight we have calculated as 1.10 grams per cc. 1.10 is G. G is how much? 2.66 as given in the question. Yeah, over here. 2.66. Then we have the unit weight of water 1 gram per cc divided by 1 plus E. Upon calculating, we found E equivalent to 1.418. This is the void ratio. Now I'll be finding the degree of saturation. Wg divided by E, water content is how much? 50%. G is 2.66 and void ratio is 1.418. So degree of saturation is equal to 93.7%. 93.7% is the degree of saturation. So we have calculated natural water content, in situ void ratio, degree of saturation. Now the last thing that is remaining is the saturated unit weight of the soil. Saturated unit weight of the soil, as per the generalized equation, it is G plus E gamma W divided by 1 plus E. So the saturated unit weight is G is how much? 2.66. E is 1.418, which we found over here. 1.418 divided by this is 1.418 plus 1, 2.418, and here we have to multiply it with the unit weight of the water. All right, so that is 10 kilonewtons per cubic meter. Upon calculating, saturated unit weight is how much? Saturated unit weight is equivalent to 16.86 kilonewton per cubic meter. Saturated unit weight is equivalent to 16.86 kilonewton per cubic meter. So with this, we have completed question in all respects. We have completed and calculated each and every parameter, the natural water content, done in situ void ratio, degree of saturation, and saturated unit weight of the soil as well, which came equivalent to how much? 16.86 kilonewtons per cubic meter. All right. So moving on to the next one. The next question is 225 grams of soil was oven dried and placed in a specific gravity bottle and then filled with water up to a constant volume mark made on the bottle. The mass of the bottle with water and soil is 1650 grams. The specific gravity bottle was filled with water alone up to the constant volume mark and it was weighed and its mass was found equivalent to 1510 grams. Determine the specific gravity of the soil. All right, so this question is based on the determination of specific gravity of soil based on this specific gravity bottle. All right, and we have to make the calculations and we have to find the specific gravity of the soil. Question is based on the density bottle method for determination of the specific gravity of soil solids. All right, and we know that in density bottle method, G is equal to m2 minus m1 divided by this generalized equation for finding the specific gravity using the density bottle method, divided by m2 minus m1 M3 minus M4. All right. So the specific gravity. Now let me tell you what are these M1, M2, M3, M4 first. All right. M1 in this density bottle method is mass of empty bottle. Mass of empty bottle. M2 is mass of bottle and dry soil. Mass of bottle and dry soil. Then is M3, which is mass of bottle, soil and water. Then is M4, which is mass of bottle filled with water only. Mass of bottle filled with water. We're trying to solve as many numericals as possible in this chapter, weight volume relationships in the geotechnical engineering. Very important chapter and very nice one, very conceptual. A good quantum of questions come from this topic in all the competitive exams. All right, so let's do this. So in this density bottle method for the determination of the specific gravity of the soil solid particles, this is generalized equation wherein M1 is the mass of empty bottle, M2 is the mass of bottle and dry soil, M3 is the mass of bottle, soil and water, and M4 is the mass of bottle filled with water only. Alright, so this is about the density bottle method. Before moving on with the question, let me give you a quick recap of how we use the density bottle method for determination of the specific gravity. This density bottle method is, as you know, is used for the specific gravity determination of soil solid particles in a laboratory. And this bottle, the density bottle, this density bottle is of 50 ml capacity. Generally, we use a density bottle of 50 ml capacity, and it's a bottle fitted with a stopper and having a hole on top. So density bottle method for determination of specific gravity of soil solid particles. We use this method for the lab determination of the specific gravity, and this density bottle is usually of 50 ml capacity and it's fitted with a stopper which is having a hole at top. This density bottle is clean, then it's dried at a temperature of 105 degrees centigrade to 110 degrees centigrade, and it's then cooled. The mass of the bottle, including that of stopper, is taken, and about 5 to 10 grams of oven dried sample of soil is taken in the bottle and then it's weighed. If the sample contains particles of large size, it shall be ground to pass a 2 mm sieve before the test. Alright, if the sample, as already discussed, I told you that about 5 to 10 grams of the oven dried sample of soil is taken in this bottle and it's weighed then subsequently. But if the sample contains particles of large size, it shall be ground to pass a sieve of 2 mm size. Alright, then this distilled water, note it down, distilled water is then added to cover the sample. The soil is allowed to soak in water for about 2 hours, and more water is added until the bottle is half full. Then air entrapped in the soil is expelled by applying a vacuum pressure of about 55 centimeters of mercury for about 1 hour in a vacuum desiccator. In a vacuum desiccator. Alternatively, we can remove this entrapped air by gentle heating. This may also be noted. So either by gentle heating or by using a vacuum desiccator, we remove this entrapped air. And then more water is added to the bottle to make it full. First we made it half full, then we'll make it full. And the stopper is inserted in the bottle and its mass is then taken and the temperature is also recorded. And the bottle, this density bottle, is then emptied, is washed, and then refilled with distilled water. The bottle must be filled to the same mark as we have done in the previous cases. And then the mass of the bottle filled with water is taken, so we get all these parameters, my M1, M2, M3, and M4. We arrive at them subsequently. Following this whole procedure and with the help of the generalized equation, we arrive at this specific gravity of the soil which was tested in this density bottle method. All right, so let's solve this question. This was a quick recap of this density bottle method, that how we make use of this density bottle, which is a bottle of about 50 ml capacity having a stopper and which is having a hole at the top. That's how we take this oven dried soil, and how we weigh it, then how we add the distilled water, then make it half full, then full, then how we remove the entrapped air either by applying a vacuum pressure of about 55 centimeter of mercury for about 1 hour in a vacuum desiccator, or alternatively we can also expel the entrapped air by gentle heating. Then how we add more water, then its bottle is again emptied, it's washed, then it's refilled, and that's how we arrive at these parameters M1, M2, M3, and M4. All right, so then we make use of the generalized equation, and we have our specific gravity of that particular soil that was tested in this density bottle. All right, moving back to the question and to the data. Now I have to use these parameters that have been given, and I have to find the specific gravity. Now listen carefully. 225 grams of soil was oven dried and placed in a specific gravity of bottle. All right, so the mass of soil, mass of soil, how much? 225 grams. What is given then? Then we have been given 225 grams of soil was oven dried and placed in a specific gravity bottle and then filled with water up to a constant volume mark made on the bottle. The mass of the bottle with water and soil is 1650 grams. The mass of the bottle with water and soil. The mass of the bottle with water and soil is how much? So my M3 is 1650 grams. All right, mass of the bottle with soil and water over here. All right, then it says the specific gravity bottle was filled with water alone up to the constant volume mark, and it was weighed and it was found to be 1510 grams, M4. Mass of the bottle filled with water, M4, is how much? 1510 grams. 1510 grams. Determine the specific gravity of the soil. So here you can see I have mass of soil, I have M3, I have M4. But in equation, listen carefully, I have M3, I have M4, I don't have M1 and M2. M1, mass of empty bottle, and M2, mass of bottle and dry soil. We don't have these things, but we have mass of soil. That is how much? 225 grams of soil was oven dried and it was then placed in this specific gravity bottle. So listen carefully. What is M2? Mass of bottle and dry soil. What is M1? Mass of empty bottle. Alright. Here in the equation you can see in the numerator as well as in the denominator, M2 minus M1, that is mass of bottle and dry soil, is the M2, minus M1, which is mass of empty bottle. M2 minus M1. this and this will cancel out. We will only be left with the mass of dry soil. That is why in the question it has not provided us M1 and M2 separately. Rather, it has provided only the mass of dry soil. Alright, so don't get confused. In the generalized equation, I don't have M2 minus M1, I have, but we don't have M2 and M1 separately. Alright, so let me make use of the parameters. M2 minus M1, mass of bottle and dry soil, minus mass of empty bottle, so mass of dry soil, that is 225 grams of soil. So here G is 225 in numerator. In denominator over here it's also 225 minus M3 minus M4. We have M3. M3 is mass of bottle, soil and water, which is given in the question as how much? M3 is 1650 grams. So here it becomes 1650 grams minus M4. M4 is the mass of the bottle filled with water only, and that has been given in the question as M4 is 1510. 1510 grams. Upon calculation, G is equal to 2.64. So that's how I calculated the specific gravity of the soil that was tested in a density bottle using the density bottle method, and that's how I arrived at the specific gravity of the soil that was being tested, and it came equivalent to 2.64. All right, so moving on to the next one. Next question is, all right, it is required to determine the water content of a wet, silty, sandy sample of soil weighing 400 grams. This mass of soil was placed in a picnometer and water filled up to the top of the conical cap and weighed. Alright, its mass was found equivalent to 2350 grams. The picnometer was next filled with clean water and weighed, and its mass was found equivalent to 2200 grams. Assuming G as 2.67, determine the water content of the soil sample. Alright, so this question is based on the water content determination of the soil sample using a picnometer. Alright, this question is based on the picnometer method for the determination of for water content determination. So I'll be solving this question. The generalized equation or the formula for the determination of water content by this picnometer method is this. Water content is M2 minus M1 divided by M3 minus M4. Here G minus 1 divided by G minus 1 into 100. This is the general equation for finding the water content using the picnometer method for the water content determination of the soils. Alright, so this is about this. Now before proceeding with the question, let me give you a brief recapitulation of how we use a picnometer to find the water content. Picnometer, as you know, is a glass jar of about 1 liter capacity. Density bottle was 50 ml. This picnometer is a glass jar of about 1 liter capacity, and it is filled with a brass conical cap. Brass conical cap. By means of a screw type cover, the cap has a small hole of 6 mm dia at its apex. A rubber or a fiber washer is placed between the cap and the jar to prevent the leakage. Alright, there is a mark on the cap and also on the jar. The cap is curved down to the same mark such that the volume of the picnometer used in calculation remains constant. The picnometer method for the determination of water content can be used only if the specific gravity is known beforehand. All right, we can only make use of the picnometer method for the determination of the water content in soils only when the specific gravity of the soil solids is known to us beforehand. Because as you can see in the generalized equation, we have G. So if we will not be having or knowing what is the specific gravity of the soil solid particles, we won't be arriving at the water content determination by this picnometer method. All right, so this is a certain limitation of the water content determination by the picnometer method, that we must be knowing the specific gravity of the soil solids beforehand. All right, or before conducting the test itself. We can use any alternate method for the same thing, or as you can see, we can even use the pictometer method for the determination of this specific gravity of the soil solid particles. But that we have to use prior to making use of the same pictometer for the determination of the water content of the same soil. All right, so this was about the pictometer, which is a glass jar of about 1 liter capacity, and it is fitted with a conical cap, a brass conical cap rather, by means of a script type cover, and this cap has a small hole of about 6 mm diameter at its apex, and the rubber or a fiber washer is placed between the cap and the jar to prevent the leakage. All right, now how do we proceed with the test? A sample of wet soil about 200 to 400 grams. A sample of wet soil of about 200 to 400 grams is taken in the picnometer, and then it's weighed. Water is then added in to the soil in this picnometer to make it about half full. The contents are thoroughly mixed using a glass rod to remove the entrapped air. All right, the contents are thoroughly mixed with a glass rod to remove the entrapped air. More and more water is added, and the stirring process is continued till the picnometer is filled flush with the hole in the conical cap. Then the picnometer is wiped dry and then it's weighed. The picnometer is then completely emptied and it's washed thoroughly and filled with water alone, flush with the top hole. The top picnometer is then wiped dry and it's weighed, and then we find M1, M2, M3, and M4. What are those? M1, mass of picnometer. M2, mass of picnometer plus wet soil. M3, as I told you before, a sample of wet soil of about 200 to 400 grams is taken in the picnometer and then it's weighed. M3, mass of picnometer plus wet soil plus water. M4, mass of picnometer filled with water only. Filled with water only. Alright, so let's see what data has been given, and accordingly we have to use the generalized equation to find the water content. Listen carefully. It is required to determine the water content of a wet, silty, sandy sample of soil weighing 400 grams. Mass of wet soil. How much? 400 grams. Moving on. The mass of the soil was placed in the picnometer and water filled with the top of the conical cap and weighed. M3, it is giving it in the question itself that M3 is 2350 grams. M3, 2350 grams, as M3 is the mass of picnometer plus wet soil plus water. It is giving it, the picnometer was filled with clean water over here. The mass of the soil was placed in a picnometer and water was filled up to the top of the conical cap, and it was weighed and was found to equivalent to 2350 grams. That means mass of picnometer plus wet soil plus water is 2350 grams. The picnometer was next filled with clean water and weighed, and its mass was found equal to 2200 grams. That means M4, which is the mass of a picnometer filled with water only, is 2200 grams. M4 is 2200 grams. All right. M4 is 2200 grams. So I'll be making use of the equation and will be arriving at the water content. Water content is given by, see again, you can see over here, M2 minus M1 is in the numerator only, and M2 is mass of picnometer plus wet soil, and M1 is mass of picnometer. We have not been given M1 and M2 separately, but rather we have been given, same as the previous question, we have been given the mass of the wet soil. That means M2 minus M1 will become mass of picnometer plus wet soil minus mass of picnometer. So this and this will cancel out. We will only be remaining with, only be having mass of wet soil. So here I'll be placing mass of wet soil because I don't have the M2 and M1 separately. So it becomes 400 divided by M3 minus M4. M3 is 2350. M4 is 2200. G. Very important. Before knowing the specific gravity, we cannot make use of the picnometer method for the water content determination of the soils, as already discussed, assuming G 2.67. So here it will become 2.67 minus 1 divided by 2.67 minus 1 equation multiplied by 100 upon calculating water content is equal to 66.79%. All right. So the water content is how much? It is 66.79%. All right. So this was about the picnometer method test for the determination of the water content of the soils. All right. And you also know now that before making use of this method for the water content determination, the only parameter that we must be knowing beforehand is the specific gravity of the soil particles. All right. With this, we conclude today's video lecture. I hope it was useful and I hope you enjoyed this. Thank you for watching this video.